Hello students, this is a review of a position time graph, and I've color-coded it for you here. We have displacement in red, time elapsed in blue, average velocity in purple because red divided by blue makes purple, and then this is the velocity at each leg of the trip. So if you look at it, here's the trip, and here's the first leg, second leg, third leg, and then we have the total. So just a review of what we're looking at on these axes. This right here is position in meters, and remember that these numbers represent actual physical locations along the earth, and these are listed in 0.1 meter intervals. So 0.1 meters is equal to 10 centimeters. So whatever this thing is, it's not moving very far, and we have a distance of 0 to 2 meters, which is not far at all. So let's start with the total displacement, and this is the total displacement in the entire event. So we're going to start with x2 minus x1. So the starting position at a time of 0 is this spot right here, which is equal to 0.5 meters. So x1 is 0.5. And the ending spot, when it's done moving, at the last recorded time of 10.0 seconds, is this location, 1.8 meters. So we would do 1.8 meters minus 0.5, and the displacement for the whole trip is 1.3 meters. Now we have to figure out the difference in time for the whole trip. So the starting time, t1, is 0 seconds, and the ending time is 10.0 seconds. And this one's easy, just subtract, and you end up with 10.0 seconds. And now if you take this displacement and you divide it by the delta t, or difference in time, remember that this is difference in position, or x2 minus x1, you would get 0.1 meters per second. And now, if you were to do this for each of the legs, you would look at the first leg, which is just this little sliver, and it looks like it lasts 2.0 seconds. So the first thing you would do is you figure out the displacement. So at a time of 0 seconds, the thing is here at 0.5, and then 2 seconds go by, and the thing is still here at 0.5, so it has not moved. So you could do x2, which is 0.5, minus x1, which is also 0.5, and you would get a displacement 0.5 meters minus 0.5 meters, which is 0 meters. And then you would divide by the elapsed time. So t2, the ending time, is 2, and t1 at the beginning is 0. So 2 minus 0 is 2 seconds. So you would divide that out, and you would get an average velocity of 0.0 meters per second. So for this part of the exercise, you have to figure out the displacement along this little leg, and the elapsed time along the leg, and then therefore the velocity, the average velocity along the leg. Now, be careful when you get to legs 2 and 3, because there's something that happens. If you look at leg 2, you'll notice that leg 2, the thing is done moving at 8.0 seconds, but it started with this leg 2 seconds into its entire trip. So the elapsed time for leg 2 only is not going to be 8 seconds. It's actually going to be 8 seconds minus 2 seconds for a total of 6 seconds. And then you would figure out the displacement, and you would take this value, 1.8, and you would subtract this value at starting location, 0.5, and you do all that, and you get an average velocity of this. So you can work your way through leg 3 as well, and then move on to the exercises.